Hi guys, we're back today again looking at the properties of quadrilaterals. We really just have two quadrilaterals left. We have what's called the trapezoid. Now, when I say two, we're actually going to look at two types of trapezoids today though. So we have a regular trapezoid, and then we also have an isosceles trapezoid. Okay, and then the last shape that we're going to look at is called a kite. We're going to be looking at the same types of properties. We're going to be looking at the sides, we're going to be looking at the angle measures, and we're going to be looking at the diagonals. Once we get through with the trapezoid and the kite, it's going to be just about time then for your exam. You'll have a short homework assignment after this. Then you'll have your quiz, and then after your quiz, it'll be time for the exam. So again, if you need to grab a sheet of paper, pencil, if you need to pause the video at any time so that you can take some notes, please do so as we work through. All right. So we're going to look at the sides. Well, with a regular trapezoid, there's not much to say about the sides. I do have one pair of parallel sides. Now, the funny thing about calling that a side is see where the red angles are to indicate that they're parallel? We actually consider that base 1 and base 2. All right, so those are actually considered the bases. But they are parallel, so I do want to make sure that you understand how that works. And the reason that that's going to be important is when we talk about our angle measures, it's going to be important to know those are parallel. All right, so then in an isosceles trapezoid, I also have the same pair of parallel sides. And again, we consider that base 1 and base 2. But in an isosceles trapezoid, much like in an isosceles triangle, we do have two sides that are equal. Okay, so in an isosceles trapezoid, I do have a pair of equal sides. All right, then let's look at the kite. I have two pairs of equal sides. Notice the double tick marks here. The longer sides that are on the bottom of the kite are going to be equal to one another, and then the two shorter sides on the top of the kite are going to be equal to one another. So two pairs of equal sides. Okay, let's look at the angles. Again, in a regular trapezoid, there really are no properties. There's no set pattern when it comes to the angles. The only thing that I can tell you for sure that in a regular trapezoid, because it is a quadrilateral, that all of the angles are going to add up to 360. But that's true of any four-sided shape. All of the angles are going to add up to 360. Now, it's a little bit different with an isosceles trapezoid, okay? Just like in an isosceles triangle, our base angles are going to be equal. Here were our two equal sides right here, okay? And here are my base angles. But remember, when I was talking about the parallel sides, these really aren't sides, these are bases. So when I have an isosceles trapezoid, not only are these two base angles equal, but these two base angles are equal as well. Okay, now the other thing that's important to remember about this, hopefully this looks a little bit familiar to you when we were working with a parallelogram, and because base 1 and base 2 are parallel, these two on the left are consecutive and they are supplementary, so they are going to add up to 180 degrees. These two on the right, again, they're considered same side interior because they're inside my parallel lines, and they too are supplementary. So they are going to add up to be 180 degrees. So the red and the red are equal, the green and the green are equal, and then one green and one red will add up to 180 degrees. All right, so then let's look at our kite. In a kite, I have one opposite pair of equal angles. And those angles are always going to be where the shorter side and the longer side meet together. Okay, so this side and this side, those are the two shorter. Here were my two longer. So whenever you have one short side meet the long side, it's going to be that angle that's equal to its opposite angle, okay? All right, so then let's look at the diagonals. It's the last property that we need to look at. All right, looks like I'm starting with my kite. My kite has two diagonals that are going to cross at 90-degree angles. All right, now they are not equal to one another, but the long diagonal does bisect the shorter diagonal, and that's why you see these tick marks right here. Okay, now the important thing about a kite, again, my diagonals are going to cross at 90-degree angles. So if this one's 90, this one's 90, this one's 90, and so is this one. Now, what makes this unique to a kite is that divides my kite into 4 right triangles. All right, and so oftentimes we're going to use the Pythagorean theorem to help us solve for a missing side of a kite. Because if I know the length of my diagonal here, and I know this segment of my diagonal, I can use a squared plus b squared is equal to c squared, which would end up being the side of my kite. And you'll see that as we get in to some of the problems that we're going to work out. All right, in a regular trapezoid, again, there are no set patterns about the diagonals, so I don't have anything specific that we're going to look out there. But in an isosceles trapezoid, my diagonals are of equal length. All right, so that means going from corner to corner diagonally, this diagonal is equal to this one. All right, the other important thing to know is that they get cut, not the diagonals themselves, into 2 equal pieces, but when my diagonals cross, the shorter side of this diagonal is going to be equal to the shorter side of this diagonal. Okay, and then the longer side of this diagonal is going to be equal to the longer side of this diagonal. So again, they don't bisect each other, but they do have that unique property, all right, again, where it cuts the shorter sides equal and it makes the longer sides equal. All right, so that's all that I have as far as the properties go. You will have a second video that you can look at here just shortly, and it is going to walk you through some problems that are unique to a kite and to a trapezoid. I'll see you then.